800 bus riders per day at a fare of $1.85. Now, the city wants to reduce pollution by getting more people to ride the bus, yet at the same time, they want to be able to maximize their revenue. So they know that for every 5-cent decrease in fare, they're going to have 800 more people riding the bus, the transit. So the question is, what fare should they charge to produce the greatest revenue? So I've already defined my variables, as you can see here. I have R representing the revenue, and this is the tricky one. X represents the number of price decreases. Okay, keep that in mind, by 5 cents. So now I have to set up the equation. So let's zoom in here and set up an equation. So I know that my revenue R is equal to 24,800. And if I subtract 800x, which is the number of riders, times $1.85, oops, $1.85, and then it's the other way around. I add 800, and every time I subtract, 5 cents from the fare, I will get more riders. Now you notice that what I'm doing is I'm actually adding multiples of 800, of course based on x, which is an integer, as I subtract multiples of 5 cents, which again is based on the x. And what I want to find out is the maximum revenue. Now there are a few ways to do this. The first way, which might be the more common sense approach that you might want to take, would be to expand and collect like terms, turning this into standard form, thereby then turning it into vertex form by completing the square. The thing is, it's a very long and tedious process, and we don't want to get bogged down using calculation, because at the end of the day, all we really care about is what fare will produce the greatest revenue. And if you look at this on a parabola, okay, here is my x and y axis. I know this is going to have a maximum based on the question. What I'm looking for is the number over here that will produce the greatest revenue. This is revenue here. This is number of price decreases. So number of price decreases by 5 cents. Okay, so this is going to be over here at some point. So how do we figure that out? Well, what I'm going to do is find the roots of this equation, which are these numbers over here. Now, because this is in factored form, finding the roots is not going to be that difficult. Okay, what we do is we take each binomial factor one at a time. So I'm going to start off with the first one. And what I want to find out is what value of x will make this equal to 0. In other words, what value of x will make this in equation form equal to 0. And this is just a question of solving a simple linear equation. So I have negative 24,800, divide both sides by 800, and what I end up with is negative 31. So there's my first root. My second root is going to come from this binomial factor. Again, let me copy it, paste it over here. And again, the question is, what will make this equal to 0? Once again, if I solve, I end up with negative 0.05x is equal to negative 1.85. Divide both sides by negative 5 cents, so negative 0.05, negative 0.05, and I end up with x equals 37. So let's go back to our picture. What we have here is the roots of 37 and negative 31. So the number we're concerned with is, well, what is it that happens here in the middle? What it ends up being is the average of the two roots. So I have negative 31 over here plus 37 divided by 2, and this gives me 6 divided by 2, which equals 3. So if I have an x value equal to 3, I will get my maximum revenue. And that's not really what I'm interested in. Again, the question was what fare will produce the maximum revenue? And if we remind ourselves that x represents the number of price decreases, that fare will be $1.85 minus 0.05 times 3, which gives me $1.70. And that is the fare that gives me the maximum revenue. Again, where did I get this number? I got it from this binomial factor, which gives me the price of an actual ticket.